Validating runtime application state against its solution architecture designed in Enterprise Architect. Having solution architecture model, you can connect to live Kubernetes cluster to verify the runtime state versus its design. The system will match solution architecture model elements with runtime components and present the in the architecture compliance table. You can verify how the architecture model mapped to Kubernetes components, including their name, type and namespace in the cluster. If solution architecture model is reflected in actual runtime state, the architecture compliance flag is set automatically. After validating solution architecture compliance, it is time to scan application components dependencies observed at runtime to make sure they reflect actual design of the solution. The Dependency Analyzer functionality provides a report displaying actual dependencies observed at runtime mapped to dependencies designed in the solution architecture model. Here, grouping dependencies by application boundary, we see that there are two external dependency items showing one dependency that is present in the model and one dependency that is observed at runtime. The system detects that there is an existing inventory management application that has existing runtime dependency to our designed pet store application. However, the version observed at runtime differs from the version present in the model. We can now browse the application architecture model in the repository to explore details of the application with the observed dependency. We see that a new version of the application that has dependency to our API has been created in the model. Our solution architecture model is not up to date. There is Resolve Observed Dependencies functionality. Let's use it to automatically update Enterprise Architect model to reflect state observed in the examined runtime environment. Now, the model contains newly created, observed relationships. We can now use the functionalities of the versioning plugin to update the diagrams and underlying model. The diagram is automatically updated to reflect the newest versions of the elements. After updating architecture model, we can now repeat comparing model state with runtime state. Now, we see that all of the component dependencies of the solution architecture model are confirmed in the target runtime environment. Check out our other videos to see how Sparx Enterprise Architect add-in for Kubernetes could help you streamline your IT solution architecture work.